Hello everyone, Sean here from Crown Technologies. We help people reach their goals with the best clean power, air and water systems. Today we're going to be taking a quick look at the temperature differences you could expect from our two low energy air conditioning systems. The first one is called Indirect Evaporative Cooling by Sealy International, fantastic company, been around since 1976. They know what they're doing and they give us excellent service for about the last 8 years. The alternative is the Breeze Air, which is a direct evaporative cooler, also by Sealy International. Very well known. This has been around for many, many years. Where do we get the names direct and indirect evaporative cooling? Well, the short answer is the air being supplied into the building from a direct evaporative cooler is making direct contact with the water being used as a coolant in this case. The indirect evaporative cooler will add a little bit of moisture, in this case the CW3, but some of the more sophisticated ones like the CWH15 will add zero humidity to the air. A lot of folks say, well, Sean, if I purchase these two different options, what kind of temperatures can I expect inside my space, my office, my factory, my warehouse, my home? Well, the short answer is it depends on the ambient conditions of the day. So here's a very helpful little cooler discharge temperature chart, and on the left is the ambient dry bulb temperature. It's a fancy word for saying what is the temperature of the air outside. And on the top we have the ambient relative humidity, so how humid is the air. Your typical conditions here in Gauteng will be approximately 30 degrees Celsius at about 30% relative humidity. And what you can expect at the bottom or the discharge area of the cooler is, all we do is we line it up, 30 degrees Celsius, 30% humidity. You can expect approximately 20 degrees Celsius off the bottom of your cooler. What we now need to consider is the losses in cooling. If you have a roof-mounted cooler and just a straight steel dropper straight down to a plenum on the bottom, your increase in temperature will be very little, 0.2, 0.4 degrees Celsius. If, however, you have a flexible ducted network running throughout a ceiling cavity, as we find in your typical home, there might be significant more heat pickup. It depends on how well insulated the flexible ducting is, how long are the duct runs, how many bends and turns are there in the duct, and how well insulated the roof is. So you could pick up anywhere from 0.5 to another 2 degrees Celsius, which means that the temperature at your ceiling, your delivery point, the grill inside the ceiling, could be between 20.5 and 22 degrees Celsius. From there, the air needs to displace the heat energy inside the room and push it out through open doors and windows. This process, again, you could pick up another 1 to 2 degrees Celsius. So quick summary, 20 degrees at the bottom of your cooler, another 2 degrees through the flexible ducted network and all the twists and turns and the heat in the ceiling cavity, delivers the air at the ceiling at 22 degrees Celsius, picks up a bit more heat energy as it's pushing that heat energy out through the open doors and windows. It's 24 degrees Celsius. What I'd like to point out is the airflow of that direct evaporative cooling system. So the direct evaporative cooling system relies heavily on the wind chill factor, which is the breeze. And here you can see that this is delivering 11,050 cubic meters per hour of air. If we change that down to second, it's about 3,000 liters per second of air being delivered into the space, your office, your warehouse, your home. And this is what adds to your cooling effect. So whilst the actual temperature of the air in your space might be 23 or 24 degrees Celsius, because of the wind chill factor, you can minus another 2 degrees Celsius. So the real feel will be 21, 21 and a half, 22 degrees Celsius. I'm sure you've seen that many times on your weather app. It might be 29 or 30 degrees outside, but because there's a nice breeze, your weather app will say your real feel is 27, 28 degrees Celsius. So this will be a similar scenario here. However, because the water is being used to make direct contact and cool the air, your humidity is increasing from 30% up to between 70 and 80%. Now, this is fantastic for human consumption. Skin, eyes and sinuses all prefer slightly more moist air. Anywhere between 50 and 80%. It tends to vary from person to person. Some equipment might benefit from these humidity conditions as well. We've done so many print shops over the years where the printers function optimally at between 70 and 80% humidity. So Climate Wizard is an indirect evaporative cooler, and today we're going to be talking about the CW3. This will only add approximately 1/4 of the humidity that the direct does to the indirect air supply. So if we take a look at the similar conditions, 30 degrees Celsius in Joburg, 30% relative humidity, you can expect a cooler discharge temperature of almost 3 degrees lower than the direct evaporative cooler. This is also done at a slightly lower airflow. So here, instead of 3,000 liters per second, this will deliver the air at 1,300 liters per second. So it's much colder air. It's a quarter of the humidity, probably between 40 and 45%, and the air is moving much slower. This is the long and the short of the question. What temperatures can I expect in my room? So with Climate Wizard, you'd be looking at a real feel of 21 degrees Celsius given these conditions. Thank you for watching. We look forward to helping you reach your goals with the best clean power, air, and water systems.